Verdant Tech here, and today we're going over the finished product of our mini ITX build. So a little bit of a recap for those of you that haven't been following the channel. This mini ITX build is actually a reiteration of a previous ATX build I did, which was my first system. So we ended up taking the core components out of that build, which was my CPU, GPU, and the RAM. So scaling down the build, that left us with purchasing a different case, a mini ITX motherboard, a different cooler because the H150i from the last build wouldn't fit into this form factor, and a SFX power supply. So we basically just took the performance from the ATX build we had and crammed it into a much smaller footprint. So for this video, I'm basically just going to be going over the parts we use along with the build process. I probably won't be going over the performance stats such as the frame rates that we're getting along with the temperatures. I'll be saving that for a future video. So starting off with the case, we chose the Ncase M1, and this is the version 6 model. So my first thoughts and impressions on this case, it's just flat out awesome. It's an absolute pleasure to build in, very convenient, well thought out, and for being such a small form factor, it's really not an inconvenience to work in. The build quality is definitely great, with over 90% of this case being machined metal, and for such a small case, it really gives you a lot of options, having extra mounting brackets for hard drives, or the option to water cool your CPU with an AIO. Now the only thing I've heard the Ncase M1 catching some flack for is its premium price point, which is right around $200. So many people suggest going with the Lee TU150, which is an ITX case that looks very similar to the M1, but definitely has its differences. The TU150 does have a slightly larger footprint and includes a tempered glass side panel, which might sacrifice cooling power compared to the M1, which has a aluminum side panel that is ported all the way down. Moving on to the motherboard, initially we installed a Asus ROG Strix B360i gaming motherboard. Unfortunately, I accidentally purchased this motherboard used from Amazon. For those of you that watch Build Vlog 1 kind of know the story, but we purchased this one used from Amazon, and when I got it in and installed it, it did not work. And after a number of troubleshooting methods, we could not get this motherboard to start and post. So with no new inventory available for the ROG B360i, that led us to the Asrock Z390 Phantom Gaming ITX. This definitely ended up being a blessing in disguise due to the fact that the Z390 Phantom has much better cooling power along with 8th gen and 9th gen Intel compatibility. So that leads us into the CPU, which as of right now we're using a 8th gen Coffee Lake CPU, which is the i5-8600K. This CPU comes with 6 cores, 6 threads, and a base clock of 3.6 GHz and a max turbo clock of 4.3 GHz. The i5-8600K has definitely been a favorite of mine due to its price to performance value. As far as Intel's lineup goes, I know AMD does have a really competitive offer, such as the Ryzen 5 3600X, which does give you more threads at a slightly lower price, but just comparing this with other Intel chips, this is a really good one to go as far as price to performance. Now discussing the most popular component and most talked about component that's inside a PC, the graphics card. And for this build we are using the RTX 2060 Founders Edition, and this is just the regular 2060, it's not the 2060 Super. Ever since I purchased this card, I've just been so impressed with the performance considering the price point that this card comes in at. I purchased this card very shortly after its launch, and I believe I paid around $349 for it. What sold me the most on this particular GPU was the fact that I could game so comfortably on my Alienware AW3418DW, which is a 34-inch ultra-wide monitor at 3440 by 1440 resolution, and it runs it like an absolute champ. For the titles that I play most frequently, I can run high settings and easily hit the 60 FPS mark, and many times way above. For the RAM, we have 16 gigabytes of the Corsair Vengeance RGB. For our CPU cooler, we went with the Noctua U9S. From everything I researched, the U9S, for its size and in this price category, had some of the best performance as far as thermals go, and for the size heatsink that it is. I also added the additional 92mm Noctua fan just for some extra cooling off of the heatsink. As many of you guys noticed, I didn't quite mount the heatsink on right the first time. It wasn't wrong, but I just kind of went the hard way, not mounting the brackets to the board first, as I should have. For some extra cooling, I also installed two of the Noctua NF-F12 case fans in the bottom. These are some of Noctua's premium heavy-duty industrial fans, typically known for their high RPM speed and heavy-duty cooling. I went with these kind of out of curiosity. I really wanted to see how much cooling performance I could get out of two 120mm fans like these. The biggest drawback with fans like these and other high RPM options is the fact that when running at high RPMs and high performance modes, you will get increased audible noise from them. Powering this little system, we have a Corsair SF600. This is a fully modular power supply with 80+ gold power efficiency. It's definitely cool to see this much power packed inside such a small form factor. With the components that we have in the system, we still have about 250 watts of headroom, making this power supply the perfect option for running this system and possibly upgraded hardware in the future. Last but not least, we used a 1TB M.2 drive from Western Digital, and this is a M.2 drive in a SATA interface. That is going to wrap up build vlog 2. Hopefully you all enjoyed this video. This was kind of a recap on the parts I used and how everything tied in together. As you saw, I time-lapsed the rebuild of this system due to you guys probably not wanting to watch build vlog 1 all over again, as the steps were pretty identical with the exception of me putting the cooler on the easier way this time. Now that this system is fully assembled and operational, I will have some more videos on this system, probably another one in the future having to do with cable sleeving, as we're going to do custom cables for this build eventually, and I will probably be making another video on performance and how the thermals are inside this small form factor build, along with frame rates and rendering performance. If you guys enjoyed the video, make sure to give it a thumbs up, and if you want to see more tech related videos like this, make sure to give us a subscribe. As always guys, thanks for watching, and I'll see you in the next video.